Hi, welcome to this lesson on Euclidean geometry, the proportionality theorem. Let's have a look at question 2. Alright, so what are we given? We're given a triangle, HJI, so this big triangle, and there's another smaller triangle, KLJ. Notice that the base HI and the base KL of those two respective triangles are parallel to each other. So this means we can invoke the proportionality theorem. We're given that the length of HI is 20 centimeters, so let's label that. KL is 14 centimeters. JL, so this short length here, or longer length, is 18 centimeters. And HJ, this longer length, is 32 centimeters. We want to calculate the values of IJ and KJ. So IJ is this length over here. So IJ is this larger length. That's IJ. And KJ is this short length here. Alright, to one decimal place each. So let's have a look at some of the proportionalities that we can use. Well, I can first of all see that in this triangle, because of the parallel lines, right, HI and KL, I immediately like to put some information on the triangles. So this angle here and this angle here are equal, so I'll say that angle IHJ is equal to angle LKJ, and that is because HI is parallel to KL and this is corresponding angles equal. Okay, similarly, these two angles will be equal for exactly the same reason. So I can say that HIJ is equal to angle KLJ. Okay, and exactly the same reasoning. And then this common angle J is equal to itself. Okay, so there are similar triangles going on, and that was the whole basis of the proportionality theorem, right? The whole basis of the proportionality theorem was that we had similar triangles that we could compare, right? And then also use that as a proof for the proportionality theorem. All right, so now that we've got that out of the way, the reason why I needed to do that is because I know these side lengths here, so they're going to be useful to me. Okay, so I've shown that triangle JHI is similar to triangle JKL. Okay, in that exact order, because this angle J is equal to itself. Okay, angle J equals angle J. It's a common angle, right? And then I've shown that angle H equals angle K. That's this first one here. And I've shown that angle I equals angle L in that last result there. So because they're similar, I can use the proportionality of them to find the missing lengths. Okay, so first of all, KJ is one of the missing lengths. So I'm going to write KJ in this smaller triangle, right, JKL, divided by a side length I know. So let's say KL. Okay, so I'm using that divided by that in that small triangle. So therefore, by that same proportion, it must be this long side divided by this base here. So it must be HJ over HI. And you can see that that makes sense in this triangle, right? KJ, or JK, is here, divided by KL, which is here. So in that same proportion, HJ is here, and HI is here. So you can see that matches up. Okay, KJ is what we're looking for, so I'm going to cross multiply both sides by KL. So first of all, HJ, that is what? 32 centimeters. Divided by HI, that was 20 centimeters, times KL, which was given to us as 14 centimeters. So I find that on my calculator. So that's going to be, let's just bring the calculator over here, 32 divided by 20 times 14, and I get 22.4. 22.4, and that is correct to one decimal place. 22.4 centimeters. Do not forget to put your units of measurement there. All right, and then for the last one, we want IJ. So where is IJ? IJ is in this larger triangle. So I'm going to say ij over a side length that I know. So we could use, let's say, hi, right? Because we know that length. So by the same proportionality, right? So we have ij, this big side, divided by hi. So in the same proportionality, we must have jl divided by kl. So jl divided by kl. And again, here's ij, this outside one, and here's hi. And then if we look here, there's jl, the outside one, and kl. Okay, so that makes sense. So we want ij, so I'm going to cross multiply both sides by hi. So jl, we have that length, that was 18 centimeters, divided by kl, 14 centimeters, times hi, which was 20 centimeters. So let's put that into our calculator. So 18 divided by 14, okay, and that was times 20. So I get 25.714, so on, but to one decimal place, that's going to be 25.7. Okay, 25.7 centimeters. All right, so we've successfully found the lengths of kj, or ij, which was 25.7 centimeters, and we found the length of kj, and kj was 22.4 centimeters to one decimal place. All right, so we used the fact of similar triangles and the proportionality that was within them because of the parallel lines. I'll see you in the next one.